this is Julie. In this video we're going to talk about the exponential form of real numbers. First of all, let's begin with a little bit of vocabulary. We'll look at an example here of exponential form. So we have this number here, x to the n power, and that's how we would read that, x to the n power. And what this means is that basically it's a shorthand for repeated multiplication. So x to the n means that I'm going to take x and I'm going to multiply it by itself n times. So if n is 2, I'll multiply x times x 2 times. If x is, or n is 3, I'll multiply x times x times x. If x is 4, I would multiply 4 x's together, and so on until I reach whatever number n is equal to. Now, when I look at this exponential form here, there's two pieces. There's the x and the n. The x is what we call the base number there, and the n is what we call the exponent. So let's look at a couple of specific examples here. So we've got, in the next example here, 3 to the second power. Another way of saying 3 to the second power, sort of a shorthand, is we say 3 squared. And that actually comes from the area formula for a square. If I want to find the area of a square, I multiply the two sides together, or I raise the length of the side to the second power, so that's where that phrase comes from. So 3 to the second power means that I'm going to take that base number 3 and I'm going to multiply it by itself a total of 2 times. So I'm going to multiply 2 3's together, and 3 times 3, of course, is equal to 9. And so if I were told to simplify 3 to the second power, that's what I would do. I would multiply out 3 times 3 and I would end up with 9 as my answer. And here again, in 3 to the second power, 3 would be the base and 2 would be the exponent. So let's look at another example. This time I have 5 to the third power. So 5 is the base, 3 is the exponent, and what this means is that I'm going to multiply 5 by itself 3 times. So 5 times 5, oops, that's not what I wanted there. 5 times 5 times 5 is what I really wanted. And 5 times 5 is 25. 25 times 5 is 125. Now, do be careful. One mistake that people often want to make is to just multiply the base number and the exponent together. So this is not the same as doing 5 times 3, which of course would be 15. This means multiply 5 times 5 times 5. Let's look at one more example here with a positive base and a positive exponent. So now I have 2 to the 5th power. 2 is the base, 5 is the exponent, and so that tells me that I'm going to multiply 2 times 2 times 2 times 2 times 2, so that I have a total of 5 2's and multiplying them all together. And again, I can kind of work my way through this here. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and 16 times 2 would be 32. So 2 to the 5th power would be equal to 32. Okay, what if I've got a negative number? In this case, I've got negative 2 to the 4th power. One thing to notice here is that I've got parentheses around the negative 2. And the reason that I want to do that is I'm showing that the entire negative 2 is raised to the 4th power. Sometimes you'll see a problem that looks like this, negative 2 to the 4th power, and that means something different. It means take 2 to the 4th power, figure out what that's equal to, and then make it negative. This means take that entire negative 2 and multiply it by itself a total of 4 times. So we've got negative 2 times negative 2 times negative 2 times negative 2. Now, if I think about what my exponent, or my positive and negative rules, negative 2 times negative 2 is positive 4. Positive 4 times negative 2 is negative 8, because a positive times negative is a negative. And negative 8 times negative 2 is going to be a positive 16. Okay, let's look at another similar example. So now we have negative 2 to the 5th power. So very similar, but this time I'm multiplying by one more negative 2. So we've got negative 2 times negative 2 times negative 2 times negative 2 times negative 2. So I already know that negative 2 times negative 2 times negative 2 times negative 2 is positive 16. And if I take that positive 16 and I multiply it by negative 2, I'm going to get negative 32. So one thing to notice here is that sometimes when I raise a negative number to a power, I get a positive answer. And sometimes when I raise a negative number to a power, I get a negative answer. And the rule here is that whenever that exponent is an even number, I will come up with a positive answer. Because if the number of negatives is even, pairs of them will sort of cancel each other out. The pairs will multiply together to make positive numbers, and my answer will end up being positive. If that exponent is an odd number, then I'll always have, I'll have pairs of negatives that will multiply together to be positive numbers, and then I'll have one extra negative that I'm multiplying by at the end that will end up giving me a negative result. So anytime you see an even exponent on a negative number, you're going to get a positive answer. Anytime you see an odd exponent on a negative number, you're going to get a negative answer. So that's it. In the next video, we will look at some other properties involving exponents and products.